So today we're going to talk about how chemists measure chemical amounts. We use a unit called a mole. And a mole is 6.02 times 10 to the 23rd. We use this because atoms are really small and we can't figure out exactly how many atoms we need. And it's very hard to measure atoms. So if we use moles, we can measure that easily because we know 1 mole is that many atoms. And reactions in chemicals react in certain mole amounts, called a mole ratio. Now this number itself, 6.02 times 10 to the 23, not very easy for us to count out, right? Imagine going through and trying to count out 6.02 times 10 to the 23rd grains of sugar. That would take forever. But the reason we can use this is we could easily transfer this into a gram amount by using what we know, or what we call the molar mass of a substance. And the molar mass of a substance is just how many grams in 1 mole of that substance. Now, how do we calculate this out? Remember how every element on the periodic table has a mass under it? So let's use our friend carbon here. If you look at carbon on the periodic table, the top you have the 12, the atomic number. That's not the atomic number of carbon, Kyle. The atomic number of carbon is 6. But if you look down at the bottom of the periodic block, there's a 12.011. So imagine you see that on your periodic table. This is the molar mass of carbon. And what that means is that 1 mole of carbon equals 12.011 grams of carbon. So we know that if I need a mole of carbon, and I need to put that into my chemical reaction, I need to measure out 12.011 grams of carbon. So, not all substances are single elements, right? In fact, most of them are not. So how do we figure out the molar mass of a substance? Let's take natural gas, methane, as our example. That's CH4. If we know the formula of the substance, we can figure out the molar mass of the substance very simply. We take our carbon, and H is hydrogen. Then we put the number of atoms next to it. So we have the elements here, number of atoms. For carbon there's 1, for hydrogen there's 4. And we multiply that by the molar mass. For carbon we know it's 12.011. For hydrogen, it's 1.01. So 1 times 12.011, 12.011. 1 times 1.01, 4.04. The last step, we add them together. So we get 150, 16.051. And that's going to be grams per mole. So the molar mass of methane equals 16.051 grams per mole. Very simple to figure out the molar mass of a substance. So let's do one more as an example for you. Let's do a big one. We'll do glucose. And glucose is C6H12O6. So, I'm going to use that same chart, but however you want to do it, you can do it. So we have elements. We have carbon, hydrogen, and oxygen. Number of atoms. We have 6, 12, and 6. The molar mass. Carbon is 12.01, hydrogen is 1.01, oxygen is 16.0. So now we multiply our number of atoms times our molar mass. And that's going to give us our total. So, I'm going to grab a calculator to do this. You can absolutely use a calculator for this. In fact, I encourage it. We get 72.06. .12 and 96. Now the last step is to add our totals together. And we get 180.18 grams per mole. So, what you're going to be doing starting today is practicing figuring out the molar masses of both elements and substances. Tomorrow, there'll be a new video posted to show you how you can figure out moles of a substance from grams of a substance. Where this is all going is we're going to be looking at another gas law called the ideal gas law that involves using moles. We're going to be doing a little bit more math. I know you guys all love to do the math, but it's okay. I'll be here. We'll hold the live sessions. I'm going to record more videos for you to watch for this part to get you through this part. So, good luck with this tomorrow. Please do not hesitate to reach out if you have any questions.